Hello everyone. In this video, we are going to discuss about the various steps in feature engineering. So there are basically 5 steps in feature engineering, which we already mentioned in our previous video about introduction to feature engineering. Let's now recall the various 5 main steps of feature engineering. The main steps of feature engineering are feature creation, feature transformation, feature extraction, feature selection, and feature scaling. Okay, so the main steps of feature engineering are feature creation, feature transformation, feature extraction, feature selection, and feature scaling. Let's learn about each step in detail. We will just spend 2 minutes on each step so that we will be able to understand what is the meaning of each step. So the first step in feature engineering is feature creation. So what is meant by feature creation? Feature creation is nothing but it is the process of generating new features based on domain knowledge or by observing patterns in the data. I'll repeat the definition. Feature engineering is the process of generating new features based on domain knowledge or by observing patterns in data. So what we do in feature creation is we actually generate new features based on what? We generate the features based on either the domain knowledge or by observing, finding or detecting patterns in the data. Now, this step is a form of feature engineering that can significantly improve the performance of a machine learning model. So when we do feature creation, this particular form of feature engineering actually improvises the performance of a machine learning model. Now let's do deep dive into the different types of feature creation. We have 3 types of feature creation: domain specific, data driven, and synthetic. So there are 3 types of feature creation: domain specific, data driven, and synthetic. Now let's see what is meant by domain specific. Now domain specific is nothing but generating new features based on domain knowledge, such as creating features based on business rules or industry standards. Data driven is nothing but generating new features by observing patterns in the data. For example, calculating aggregations or creating interaction features. And finally, synthetic feature creation means generating new features by combining existing features or synthesizing new data points. So as we know that feature creation is nothing but the technique of generating new features based on domain knowledge or by observing data patterns. Now, for example, if it is going to be based on domain knowledge, we call that feature creation as domain specific creation. And if it is going to be generated using data patterns that are being observed in the data, then it is called as data driven feature creation. And if we are going to combine existing features, then it is called as synthetic feature creation. So that's about the first step, feature creation. Now the next step in feature engineering is feature transformation. Now what is meant by feature transformation? Feature transformation means it is the process of transforming the features into a more suitable representation for the machine learning model. So what is meant by feature transformation? We actually try to transform the created features into suitable representation which will be useful for the machine learning model. So however the feature will be suitable for, into that kind of a representation, the generated features will be transformed into. That is what is called as feature transformation. So this is why do we do feature transformation? It is done to ensure that the model can effectively learn from the data. Our main aim is to make the model learn from the data. So we have to transform our data into such a way that it is more suitable for the machine learning model. So that is the reason why we do feature transformation. Now we have 4 different types of feature transformation. They are normalization, scaling, encoding, and transformation. These are the 4 types of feature transformation. Now we will see what is meant by normalization. Normalization is nothing but rescaling the features to have a similar range, such as giving it a range between 0 and 1 to prevent some features from dominating others. So you normalize all the features. You prevent one feature from dominating another feature. So you normalize all the features. That is called as normalization. Scaling means it is a technique used to transform the numeric variables to have a similar scale so that it will be easy for comparison. And encoding means transforming the categorical features into a numerical representation. So in scaling, what do? We transform numerical values to have a similar scale. For what reason? So that it can be compared more easily. And what we do in encoding is we actually transform the categorical features into numerical representation. And finally, in the fourth type of feature transformation, that is which is called as transformation, we actually transform the features using mathematical operations to change the distribution or scale of the feature. So we use certain transformation techniques such as logarithmic, square root, and reciprocal methods to transform the features in such a way that we are able to change it to a distribution or scale of the feature. So this is what is meant by feature transformation. Now we move on to the third step in feature engineering, which is feature extraction. What is meant by feature extraction? Feature extraction is the process of creating new features from existing ones to provide more relevant information to the machine learning model. So what we do in feature extraction is we create new features from the existing features to provide more relevant information to the machine learning model. Why do we do this? So that we'll be able to make our machine learning model to learn from the data more effectively. So how do we do this? This is done by transforming, combining, or aggregating existing features. We need to create new features from existing ones. So how do we do that? We can either use transformation, or we can combine the features, or we can aggregate the features. Now coming to the different types of feature extraction. They are dimensionality reduction, feature combination, feature aggregation, and feature transformation. These are the four types of feature extraction. What is meant by dimensionality reduction? What we do in dimensionality reduction is we reduce the number of features by transforming the data into a lower dimensional space. So we reduce the number of features using dimensionality reduction. And what we do in feature combination, we combine two or more existing features to create a new one. And what we do in aggregation, we aggregate the features to create a new one. And what we do in transformation, we transform the existing features into new representation. So I will give you an example for feature combination and feature aggregation. In feature combination, what we do is we actually try to combine two or more features to create a new one. So that could be interaction between, example could be interaction between two features. And example for aggregation is calculating the mean, sum, or count of a set of features. An example for feature transformation is a log transformation of a feature so that it is getting converted into a skewed distribution. So this is what is meant by the third step, feature extraction. Now we move on to the fourth step in feature engineering, which is called as feature selection. What is meant by feature selection? It is the process of selecting a subset of relevant features from the data set to be used in a machine learning model. So what we do is now from the features that have been transformed and extracted, you select a subset of features which are relevant so that it can be used in a machine learning model. Why do we say feature selection is a very important step? Is because it can have a significant impact on the performance of the model. Feature selection step plays a crucial role in creating an impact on the performance of the machine learning model that is being built. Now we have three types of feature selection: filter method, wrapper method, and embedded method. Now in filter method, what we do is we select features with a high correlation. Okay, and in wrapper method, what is done is the feature subset which results in the best performance will be selected. And in embedded method, based on the feature selection as part of the training process of the machine learning algorithm. Now, this is what is the fourth step in feature engineering. Now, coming to the last step in feature engineering, which is called as feature selection. What is meant by feature selection? Process of transforming the features so that they have a similar scale. Why do we need to do feature scaling, or why is feature scaling important? Because the scale of the features can affect, or it may affect the performance of the model. Hence, we do feature scaling so that all the features will have a similar scale. What are the types of feature scaling? Min-max scaling, standard scaling, and robust scaling. Min-max scaling is we rescale the features to a specific range to fall between 0 and 1. Okay. And standard scaling means rescaling features to have a mean of 0 and a standard deviation of 1. And robust scaling is rescaling the features to be robust to outliers by dividing them by the interquartile range. So these are the different types of feature scaling. And in this video, we have seen what are the various steps in feature engineering, and we have also seen what is meant by each step and what is the importance of doing that particular step in feature engineering, and what are the various types of those steps in feature engineering. So with this, we will end our session. Thank you.